Hey, summer science students. This is lesson 2 of week 4. It's our last week of summer school, and including today, we have 4 lessons left, so let's get started. Okay, so just a friendly reminder that all of the quizzes in yellow should be done by now. These are the quizzes from week 3. So please try to keep on top of that as we only have a few days left. And if there is an issue with the quizzes, just get a hold of me and we'll try to figure something out. Okay, so before the next lesson, you need to read Studying Populations on GradPoint and take the quiz Studying Populations. So you read it correctly. There is only one quiz today, so that's a nice surprise. Okay, so to get to our one quiz for today, we're going to click on Unit 3. It'll take you to the screen. Click on the only folder that's there, number 1, folder 1. And here's a list of our work. Today's lesson is in yellow. Yesterday's lesson is in blue. And tomorrow's lesson is in red. Okay, so I'm going to start the grad point summary. Again, this is like an outline of what I think is the most important information that you should walk away from the lesson understanding. Remember, a population is a group of the same species that live together in the same place. So if we were back inside the classroom doing summer school, we would be a population because we're all humans that are hanging out in one classroom. It is important for scientists who are studying populations to understand the size of the population. And this is really important as our climate changes and as humans have a greater negative impact on the environment. We need to figure out what we're doing to our populations of plants and animals. So we have scientists who just study this. And the best way to study it is to understand the population size. That way you can decide, is the population increasing, is it decreasing, or is it staying the same? Sometimes it can be difficult to go out and count animals. For example, let's take frogs. Maybe you guys, when you were younger, you try to catch frogs. Frogs can easily swim away. They can hide underneath the water, underneath leaves and logs. They're camouflaged, so that means they blend into their environment, and they are shy of humans. So that's going to make it really hard for you to go out to a pond and just do 1, 2, 3, 4, because the moment that you step into the water, those frogs are going to scatter. Because of this, scientists will make an estimate of a population size. An estimate is an approximate of a number based on reasonable assumptions or guesses. So I always say estimate is like an educated guess. So you're not just pulling it out of thin air. You're not just like randomly coming up with a number. It's based off of evidence and it really is your best guess. Scientists have many ways or methods of estimating a population size. So, one way to do this is called sampling. And that's when you go out in an area and you count organisms in a small area. So, let's say you want to figure out the population of the woods in your backyard or the woods in a state park. You would only take a very small percentage of that area and just really focus on counting as much as you can in that small area. It's easier to count in a small area, right? Then you multiply that number to estimate how many organisms would be in a larger area. So you take that small square that you counted and then you take the number of organisms that you found and then you multiply it to guess what would be in the whole woods. Another way is called mark and recapture, and that determines population size by estimating the number of individuals multiple times. So what does that really mean? So scientists will try to catch or count organisms at a certain location and actually mark them. So they might put a little tag on them. They might put a little bit of paint. Then they'll go out again and try another time and see how many they've caught versus the ones that will be unmarked. And this is a way to estimate how many organisms you have in a population. So both sampling and mark and recapture studies involve estimates. So You're not getting an exact number, but you're doing your best to educate. Apologies, I think the video cut me off, so I'm just going to repeat what I said. So both sampling and mark and recapture involve estimates. So there's no way to really know the exact precise number of organisms, but scientists make their best guess based on the data that they get from these two studies. Moving on, some organisms may be harder to observe in order to count for population size. When the population of organisms are hard to observe, scientists will use indirect observation. So what does that mean? What happens during indirect observation? Well, scientists will look for clues left by organisms to estimate population size. So let's go back to our frog example. So you may not see a frog, again, because they're shy, they're easily camouflaged, they're really fast, but you can definitely hear the plop as they jump into the water. So instead of going out and actually, seeing frog, he's number 1, you see another frog, he's number 2, you see another frog, he's number 3, you will just listen to the amount of plops that you hear, the splashes of the frogs going into the water. Another example of indirect observations are animal tracks and animal homes. So these are a nest of a cliff swallow. And so you might not actually see the bird, but I could say, just based on counting the nests, there's 1, 2, 3, 4, 5. I could say that maybe 5 cliff swallows live there, and they're probably a couple, so it's more like 10. Okay, stop. We are done with studying populations. You might want to pause the video. Please take the studying populations quiz. Remember, you only have one quiz today, lucky you. And when you're done and pass with that and you don't need my help or need to get in contact with me, then you are done for the day and I'll see you back here tomorrow.